Hi everyone. Today we'll be discussing the LeetCode problem of the day, number of ways to divide a long corridor. So you're given a line of seat and plants in a corridor, which are represented by a string, where S represents the seat and P represents the plant. So for example, let's have two seats, then a plant, then seat, plant, seat, and seat. So suppose this is a corridor. And in this, you have two dividers which are already installed at the left and at the right. So at the very left and at the very right, you have two dividers already installed. Additionally, you can install any dividers between these positions. So you can install a divider either here, here, or anywhere up till here. So you have to divide the corridor into non-overlapping sections where each section must have exactly two seats, and the plants can be any number. And there are multiple ways to perform the division. So you just have to return the total number of divisions you can make, so that this property is holding, that exactly two seats and any number of plants must be present in each divided section. So for example, in this input, so a possible division is add a divider here, then maybe add a divider here. So by doing this, this is the first section which has exactly two seats, and this is the second section which has exactly two seats and two plants, and finally this is the last section which has again exactly two seats. So you can also have this as the division. So this also works because here also two seats, and two seats. This suppose we make a division like this. So this division is invalid because even though here you have two seats, but in this division you only have one seat, and in this division you have three seats. So this is a invalid division. So at the end, you just have to return the total number of ways you can divide modulo 10 power 9 plus 7. Now let us look at the example. In the first example, you have two seats, then two plants, then a seat, plant, and seat. So for this, in each division, there must be exactly two seats. So initially, you can count that there are total four seats in this entire corridor. So that means you have to make you have to add one division so that it will make two segments where each segment will have two seats. So first division can be made here, because when you do it, in the left part there are two seats, and in the right part also there are exactly two seats. So this is one possible division. And here also, if you make a division, then also it holds two seats in the left and two seats in the right. So this is the second possible division. And you can divide it here as well, because left two seats, right two seats. So you have three possible ways to divide. So you can't divide it here, because if you do it, in the left hand side you'll have three seats and right hand side you'll have one. So that is invalid. Each section must have exactly two seats. So total you can divide in three possible ways. So the output will be 3. Now coming to the second input, we have first two plants, then a seat, then a plant, seat, plant. So in this, the total number of seats is already 2. So wherever you divide, suppose you divide it here, the right part will have 2 seats, but the left part will have 0 seats. And suppose if you divide here, the left part will have 1 seat, right part will have 1 seat. So in this, the division is not possible. So you don't add any of the dividers. So the total number of ways is only 1. That is when you don't add any division. Finally, let's look at the third input. In the third input, you just have a single seat, and there's a divider at the starting and ending. So here the number of seat is only 1. So this is a segment which has total number of seats equal to 1. So this seat count is not equal to 2. So it's an invalid configuration. And since the size is 1, you can't add any dividers anywhere. So it's not possible to divide it. So the output will be 0 for it. Coming to the constraints, the array size, the string size will be n, and n can be up to 10 power 5, and it will contain only s or p. Now let's go with the approach. So one thing is clear that in your corridor, if you have the total number of seats as odd, then no matter how you divide, one of the section will have one seat remaining. So that is not a valid configuration. So we can say that in your corridor, if there are total odd number of seats, then your answer will be 0. So now let's look at a case where the total number of seats will be even, and let's see how we can solve for it. Yeah, so suppose you have this as the corridor, and initially you have a divider at the starting and the ending. And here we can see that the number of seats is 6, which is even. So we can do the division. So one thing to note here is, suppose you make a division at this point after the first S. So when you do it, the corridor will be split into two parts. So in the first part, you will have one seat, and in the second part, you will have total 5 seats. So like we discussed before, if in a corridor we have odd number of seats, then you can't divide this corridor further. So that means making a division in this point is not valid. Similarly, so these two are adjacent pair of seats. These two are adjacent pair of seats, and these two are adjacent pair of seats. So what I mean to say is, you can never place a divider in between any two adjacent pair of seats. So again, if I try to place a divider here, then the right side you'll have one seat, and the left side you'll have 5 seats. So there's an odd number, so you can't divide this corridor further. And similarly, if I try to place a divider here, then in the left hand side you'll have 3 seats, right hand side 3 seats, so you cannot divide them further. So one thing we have established is that you can never place a divider between two adjacent seats. So first two, then next two, and next two. So by this we can say that no matter what the division is, these will remain in a same segment. These two seats will remain in the same segment, and then these two, this set of seats will remain in the same segment. Like we established, we can't place a divider in between these. Now all we have to do see is where we can place the dividers. So we have 3 segments here: segment number 1, segment number 2, segment number 3. So we can see that before the segment number 1, we can't place any of the segment, any of the divider, because if we place a divider here, the right hand side will have 6 seats, but the left hand side will have 0 seats. So you can't have 0 seats in a segment, so you can't place a divider here. So same argument here. If you place a divider at this point, again left hand side, the total number of seats will become 0. So it's an invalid configuration. So that means since you have 3 segments, left hand side of the first segment, you can't place any divider. And the same argument can be made for the right hand side of the last segment. So you can't place a divider here, or you can't also place a divider here, because when you do it, the right hand side will have 0 seats. So that's an invalid configuration. Now the only possible choices to make the division are in between these and in between these. So between the segments. Now let's focus on this part, this gap between two segments. So in this gap, we can only place a single segment, single divider. Because if we place a single divider here, then these two pieces will be in this segment, and this p will merge with the left hand side segment. And suppose if we place a divider here, then this p will merge with the right hand side part, and these two p's will merge with the left hand side segment. So what I mean to say is, out of this, you can never place two two dividers, because when you do it, if you place two dividers, then this particular segment will have 0 seats. So that's an invalid configuration again. So by this, we can see that between any two segments, we can only place a single divider. And between these two segments, uh, you can place a divider here. You can place a divider here, here, or here. So the number of plants is 3. So in this, you can place total 3 plus 1, which is 4 dividers. And similarly, between these two segments, you can place a divider here, or you can place a divider here, or you can place a divider here. So between these two segments, you have 2 plants. So total, you can place 2 plus 1 equal to 3 dividers. Now, if you want the total number of ways you can split it, you just have to multiply these two. So 3 into 4 will be 12. So let's look at one of the division. So in this part, there are 3 ways. So suppose I place a divider here, and in this part, there are 4 ways. So let's say I place a divider here. Now what happens is, this entire thing is first part, and it has exactly 2 seats. And this entire thing is the second section, and it has exactly equal to 2 seats. Finally, this part will be the last section, and this also has exactly equal to 2 seats. So the approach is simply, you just need to find the segments which has 2 seats together, and you just have to multiply the number of seats plus 1 between all the segments. So that is, you just need to multiply plants plus 1 across all the empty gap in each segments. Now let's code the approach. So let's take a few variables. First will be used to count the seats, initially 0, and one variable to count the plant, and one more variable to count the total number of seats. And let's start iterating on the string. So like we discussed in the approach, we will just count how many plants are there between each of the seed segments and multiply them. So for that, let's also take an answer, and initially answer will be equal to 1. We move it down. Yeah. So if the current character is equal to a seed, then we'll increase the seed count, and we'll also increase the total seed count. Else, to make it more clear, we can have it as else if c equal to plant. Let's look at this case later. So first, initially your seed count will be 0. Yeah. So initially seed count is 0, and you iterate on here. You have a plant, then you move on. You are at here. Then when you're at here, your seed count is 1. And next you move on. You're here. Then you're here. Your seed count is 2. So once your seed count is 2, that means you have found your first section. So after the first section, whatever piece you encounter, you have to count them. So the p you have to count will be after when you found your first segment. And when you find your first segment, the count of seed will be 2. So when the current character is p, your seed count is 2, then you will increase your plant count. So currently seed count is 2, and when you're at here, you're increasing plant, so plant will become 1. Next you're at here, so again it's a plant, so plant count will become 2. After that, when you're here, so the seed count will be 3. So once the seed count is 3, that means one section is finished and the next section is starting. So before starting the next section, whatever the plant count you have, that plant plus 1, you will multiply it in your answer. So we can say that if your seed equal to 3, then answer equal to answer into plant plus 1. And once that is done, you have to reset your seed to be 1. Because you are freshly starting a new seed, so seed count will be 1 here. And also you will reset the plant count to be 0. And then you will move on. So after this, what happens in your answer, you will have 2 plus 1, which is 3. And your seed count was reset to 1. And your plant count will be reset to 0. So next you will move on to here. So it's a seed. So seed plus plus, it will become 2. Then you're at plant again. When you're inside the plant, you see that seed count is equal to 2. Then only you will increase the plant. So plant count will become 1. Then again you have a plant and you see seed count is 2. So you'll increase the plant count. Then again you have a plant. So seed count is again equal to 2. So plant will be equal to 3. After this, the seed count is, after this the character is S. So you will increase the seed. So seed will become equal to 3. So that means you found a new section. So whatever plants you encountered till now, that plant plus 1, you have to multiply it in your answer. So when seed equal to 3, answer equal to answer into plant plus 1. So 3 into 3 plus 1, which is 4. You'll have your answer as 12. And once you do this, you will reset the plant to be 0 and you'll reset the seed to be 1 and you'll move on. So next you are at here. It's a plant. So you'll go to the plant case, but seed count is not equal to 2. So you won't count this plant. Like we discussed, you won't count this plant because this plant is between 2 seeds. So you can't anyway make a partition here. So again, when you are at here, C equal to P, the seed count is not equal to 2. So you won't count this P as well. And when you're at here, the seed count will be 2. After this, there is a P. So plant count will increase by 1. And then finally you have a P here. So plant count will be increased by 1. So it will be 2. After this, the string is completed and your total answer will be 12. And that's what you have to return. And like in the question, he wants you to return it modulo 10 power 9 plus 7. So whenever we multiply it, we just take a mod to prevent the overflow. And since we are multiplying, so when you do the multiplication as well, the value can overflow. So it is better to use a long variable. And at the end, while returning, you can just typecast your answer back to end and return. Also, like we discussed, we have to check few corner cases. Move this down. Yeah, we have to check few corner cases where if the total seat count is odd, then directly you can return 0. So if total mod 2 equal to 1, or if the total seat count is equal to 0, then you can directly return 0. Otherwise, you will return your answer. Let me test it. Right. Yep, and it works. Finally, let's do the time and space complexity analysis. So the time complexity is pretty simple. We are just iterating on the string length, and inside it, we are just doing constant operations. So time complexity will be order of n. and the space complexity will be order of 1 because we are just initializing few variables and we are not declaring any arrays. I also have the code in Python. If anyone wants to view it, I'll add this in the description as well. And let's catch up in the next video.